Hey, what's up guys? Back with another video. Um, we have here a capacitance circuit from problem set 2. If you know, you know. Alright, so it says here, the figure shows a system for capacitors where the potential difference across A, B is 50 volts. Okay, 50 volts, we got these 4 capacitors. Let's check it out. I wanna draw this for you guys. So, we got like this. This is 10 microfarads. It's like this. This is 5 microfarads. We got like this. This is 9 microfarads. And then this is 8 microfarads. And then this is B, is A. Okay, so let's assign our values first, shall we? Simply, I just want to say, it doesn't matter, you can assign in any way you want. Let's just say this is C1, C2, C3, C4, because we got 4 capacitors. Alright, let's analyze our circuit, guys. So our circuit over here, we have this part. Oh, oops. We got 3 parts basically. We got this. If you think about it, this is in direct connection with this, and this is also C4 is also in a direct connection because C4 looks like C1, right? And then C2, 3, it's if you combine this, it's gonna look like this. I keep saying that. Why do I keep saying that? Basta, C1, C2, C3, C4, and they're in series. So yeah, this is basically how it looks like. As simple as that. Let's get to it, guys. Let's write down our equations. Actually, let's just down our given. C1 is 10 microfarads, 5 microfarads, 8 microfarads, C4 is 9 microfarads. Yeah. So, we already analyzed this whole circuit. It's pretty simple. We have here C23, because that's like the first thing we need to combine, is equal to C2 plus C3. Whoa! I thought they're in parallel. Why are we adding them like that? So, let's look at my master guide. Because this is a capacitance circuit. In capacitance, you just add them straight up. It's like resistance in series. Alright, so as simple as that. And then our second equation is already our CEQ, or a total. So it will look like this. Because they are all in series, capacitance, they look like this. The capacitance in series. Yeah, there's the summation of the reciprocal, and it's reciprocal. Next we have Q. Q23 is equal to our Q2 is equal to our Q. Wait, no, add Q3. Okay. If you watched my other vid, you know that Q, or charge, or coulombs, works the same way as current. Q is I. They work the same way. So remember that this here is in parallel. Okay, so since it's in parallel, remember that current, or charge in this case, is added. Okay, so let's make our other one. So KEQ, so they are equal because they're in series. So Q1 is equal to Q23 is equal to Q4. Okay, next we have our voltage. Voltage is voltage. Voltage in parallel they're equal, remember? Because if it's in parallel, they get directly from the source. That's how it's understood. VEQ, so since this is in series, it's the summation of the voltages. So V1 plus V23 plus V4. And then let's solve. So C23 is equal to C2 plus C3. You don't have to convert the micro yet if you're just combining them. If you're just combining the capacitance, you don't have to convert just yet. So C23 is equal to 13 microfarads. And then we get our CEQ to 1 over, what is our C1? It's 10 microfarads plus 13 microfarads, which is our C23, plus, let's see, I'll just write that, and then 9 microfarads raised to -1. Pretty simple, right? Okay, let me put this in the calculator for you guys. Plus 1 over 13 plus 1 over 9 raised to -1. And that will give you 3.47 microfarad. Oh yeah, I forgot to explain to you guys the units. Remember, just look at my master guide. Capacitance is farad, charge is coulombs. If you remember Coulomb's law, voltage is voltage. So like what I usually say. Okay, let's write this. 3.47 microfarads. Next, our charge. So, yeah. Remember, if you watch my other videos, the trick, if you have 2 values in a column, you can get the third one for sure. Our formula is capacitance is equal to charge over volume. So, using our formula, it's CEQ VEQ equals to our QEQ. And our CEQ, we just solve for that, 3.47. Now we convert it. Remember, the conversion is times 10 raised to -6. Our total voltage is 50. Wait, hold on. I'm getting a phone call. Okay, where was I? Okay, okay, QEQ is equal to 50 times 3.47 times 10 raised to -6, which is equal to, why is not clicking? Okay, 1.735 times 10 raised to -4 coulombs. Don't forget coulombs. Let's write this. Coulombs, yes. Okay, this is very easy because you can see that QEQ is equal to Q1 equal to Q23 is equal to Q4. Yeah. So, same thing, copy paste. And then remember, so what we need now is we need V23, so we can get V2 and V3, and yeah, actually you can just solve it now because you have C23. So but first, let's do these now, so to get them out of the way. Let's get V1 and V4. So getting V1 is equal to Q over C. Q1 over C1. V4 is equal to Q4 over C4. Then, oh wait, wait, hold on. Okay, alright, so Q1 is equal to, yeah, okay, Q1 is just this, it's just these guys. This is like this is very simple. 10 times 10 raised to negative 6. This is 9 times 10 raised to negative 6. Okay. Let's put 10 times 10 17.35. This is our V1. And then this one is equal to, alright, wait, 1.75 times 4 divided by 6, 19.28 voltage. Wait, no, 17.35 voltage. 19.28. Remember what I said? It's just easy. We get our V2 tree because we have Q2 tree. So V2 tree is equal to Q2 tree is equal to C2 tree, and our Q2 tree is equal to whatever this was. So 1.735 raised to negative 4. Our C2 tree, we solved for that, 13 micro, and this is equal to 13.346. Well, I'll just do 13.35. And this is equal to your V2, V3. And then now, it's just, I guess you see what's gonna go on. We get our Q2, Q3, which is a C2, V2, C3, V3. I'll just do that on my calculator now. 5 times 7 raised to negative 6 times 3.35, 6.67 times 7 raised to negative 5. This one is 8 times 6 times 13.35, 1.068 times 7 raised to negative 4. Yeah, there you have it. I mean, again, if you want to check your answers, add up all the voltage, which is, let's see, so V1 or V2 or V3, so 30 point, oops, 20, so what's this, 17? Yeah, 17.35. 17 plus 13 is 30 plus 19 is 49. It's about 50. So that's how you do it. You look at this. I mean, it's not foolproof, but yeah, there you have it. Thank you for listening.